Well, chat timer. Okay, so as said the last time, since today is the last lecture for this year, the next one will be after the new year, so it is a good time to think about some final project for you. And as I already suggested the last time, I think a good idea what would be a suitable final project would be for you to implement an own text editor in Qt using Qt UI with the following functionality as described already in the text file here, which I wrote during the last lecture. So we would want a general window where we can access all the different UI components, starting with a menu bar for all the supported commands, a toolbar, either with just a few most useful selected commands or optionally configurable. Then of course would be the main text edit window, which can be implemented, for example, using a Q text edit, and at the bottom a status bar where some information about the file can be displayed, like file size, encoding, current position like row, column, etc. Of the cursor, the length of the selected text, and other information like that. It would be good to implement for the control and own context menu, so that we can add there some additional function like find and go to, etc. What we also want is, as already mentioned, a find function, so that the user can open a window in which he or she or they can search for some context, some content within the document. Usually this works such that it starts searching at the position of the cursor, searches to the bottom of the text, and then starts from the top and goes again until the position of the cursor and then stops. Other implementations work such that they search to the end of the text and then just stop. A good implementation, for example, would be one which asks the user if nothing was found, whether it should search the text from the top again, or if it should finish search. Another functionality which we would want, which would be based on the search, would be an option to search and replace a text within the document. This is quite a useful feature and not much more complicated than the search replace itself. What also is quite useful is if you can change the text from uppercase, the selected text from uppercase to lowercase and vice versa. So as having some hotkey combination for that would be quite useful. Of course, any good text editor needs some undo and redo functionality. Ideally, in a way such that you can store multiple operations, so not that you can just undo one last operation, but really you can undo as well either everything until the very start or up to some reasonable cut of like the last 100 operations or something. If I recall correctly, Qt even has a helper class for that, so that should be quite easy to implement with not too much own new code to be developed. And last, the main important non-optional function for the text editor would be the ability to enable or disable word wrapping. So if you have a line which is longer than the screen, then it will just wrap into the next line. That should be doable, if I recall correctly, through a setting on the QText edit. So you won't need to change the text or something, but it should automatically work just by setting the right parameter. And now, as I mentioned at the beginning of the lecture a long time ago, homework and final projects have optional components, so things that you can do to get extra points, and here we have a small list of functionality which could be added to the text editor. One functionality would be to add the ability to not just open files from the local hard disk, but also download files directly from the internet by a provided URL. This is quite easy to implement using the QNetworkRequest class, as it is capable of supporting the whole HTTP and HTTPS protocol. I think it does not support FTP, or at least not anymore, but FTP is so old we don't need that anyways. The next thing which would be good to have would be some simple built-in calculator. So basically just a window that pops up with some calculator options. It does not really need to be tied in functionally into the text editor portion at all. Although if you have any ideas for some good integration, you are of course free to implement them. The next nice functionality would be to support alternative file encodings, so that you can open a file, for example an ASCII file, and then encode it as UTF-8 or vice versa. It would be also good to support UTF-16, but since there are like pretty much any amount of encodings around the world, there is no, I will not give you a fixed list of which encodings you have to support. You just let's just focus as a mandatory step on the basic ones: ASCII encoding, UTF-8 and UTF-16, and that's it. If you want to add anything else, then you can do it, but it is not necessary. As already mentioned with regard to the toolbar, it would be nice if you add an option for the users to customize which commands from the menu they want to have in the toolbar displayed. Ideally that would be done by having a second window that opens, where you have, for example, two columns, one which represents the toolbar and one which represents functions that you can add to the toolbar. This is usually the classical way of customizing toolbars, so it's a bit work, but it's quite let's say routine, so nothing too spectacular there. And one thing that also would be and one last thing that would be also a nice optional functionality would be a go to line double point column option. So where you specify a line and a column where you want to go, and then it will put your text cursor exactly there. This might sound super easy, but it's really is not as easy, since normally when you just have the text, you don't know where the lines are ending, so you need to go through the text and find all the line breaks. So this will need some better planning. And one last thing that also would be nice to have if you want, which is related to this functionality, would be a line number display. So modify the control that you would be using to display the text such that it would display a line number next to each line. But that is, as mentioned, optional and is probably not that easy to do. As I mentioned last time, if you have an idea for another final project that you would want to do, you can suggest it today. So question for you, does any of you have any ideas or wishes, or are you all fine with the final project as presented? Okay, no one is saying anything. Okay, since no one has any comments, then I guess you are happy with the assignment. So that will be the final project. I will add it today to Moodle. You will have time until the end of January to finish the project. When is the last lectures? I think the 25th. So let's say the 25th of January is like your soft target, and you can have 1 week extra as a hard deadline if you need to finish something else in the meantime. Yes, and for now we will continue with our Messenger application. So as you may remember, last time we have implemented the ability to transfer files. What we have not yet implemented would be some ability to verify whether the transferred file arrived intact or not. How necessary this is probably up for debate. Since we are using TCP, we can usually assume that the communication will be quite reliable, but on the other hand we might at some point want to change our protocol to maybe use UDP or some other mechanism of communication, so it would not be a bad idea to add some sort of integrity checking. So again, we will quickly test our file send functionality just to ensure that it really is working and we haven't broken anything in the meantime. As you can also see here, we show the progress in the status bar. We could change it actually to show the progress as percentage, but I just see that we still have a bug from last time we haven't fixed. We do not terminate one of the sessions. Actually, that is the sending session, so we need to find out why this is not happening, since we of course want both sessions to be properly closed. So we'll quickly debug this. So we have here our on disconnect event, so we will first see if it will be triggered for both ends of the connection. Now we will of course select a smaller file for the test so that it is faster. And maybe this one. Yes. Okay. So we get one close notification and we get the second one, but it appears that we have not connected a slot because the second one doesn't do anything. So let's see where we connect to on close, and let's search for the exact key. So right, on start transfer and on send file. Seems that we are connecting, so probably our bug is somewhere else. So let's put a breakpoint here and see if both operations will at which point in the operation we will this will break down. So again, we start a new chat, we select the file, something small, zack, hier speichern. Right, so we don't need this breakpoint. So here first we get an state, we end the session, we prepare here a deletion, so this works fine. The other one seems to work as well. So for both we trigger the function, but only one of them gets deleted. So this tells us that at some place we have a smart pointer which is still being referenced, which is not ideal. So first of all, we could put a breakpoint here just to see whether we reach the single shot timer twice. We should, but it's of course good to test. And let's just take the smallest file of all, just to be super fast in our testing. Right, 1, 2. We need to recompile. There is a setting in Visual Studio that would allow you to make changes and then have those changes applied directly when you are in a breakpoint, but this is kind of error prone, so it's better to always restart the project to be on the safe side. You would not want some random bugs to appear which are not reproducible. Okay, so as we have seen, the breakpoint is reached 2 times, so it means the single shot also works correctly. We just need to track down where we might be holding a pointer which is not being released, which by the way is not the most trivial of things. So we know that what fails is the file send side. So we first go to our send file, we create here a pointer, we connect to it, we do start, and then we add it to sessions, and we add it to file sessions. Then sessions holds our pointers, and file sessions associates the URL with the file. And then if we have our session closed, right, so we'll put a breakpoint here and then inspect the behavior of this function. I already suspect what might not be working correctly. So we start a new chat, send file. File. Right, so in this case we are issuing this end chat, and this is not what we want, and I think the issue will be that our chat session will be containing, so we will be using the same URL for file transfer as we used for the chat session. So we will want to change this behavior. This could be quite easy to do. We will just change the order of operation here. We'll remove the file URL, and if this is true, then let's see, file session is 1 and sessions, right. So if we remove a file transfer, then we don't need to do actually anything. We only need end chat in the other case. So if this is 0, then then we want to first remove the chat, and if that worked, then issue the end chat notification. Otherwise it means that we found a file session and we have removed it, so that should work. Let's try it out. Start a new chat again. We select the file. And I think it worked. Let's try with a bigger file. At least we were not stuck with a transfer message, but also we will know in a second. Yeah, we can overwrite an old file. Nope, now it isn't working for either case. That is unexpected, so let's see what might be wrong. So our file session contains here a URL this, and our chat session let's see how this behaves again. Zack. So we get we have 2 file sessions, which is okay. We get the URL and the chat session. Now we expect this to not be 0, which it isn't, which is okay, and then we go to the signature. So this behaves as expected. Let's see, but we're not removing the tab properly, so in our start file, let's see. Probably the chat ended event we need to emit every time, whether any of those two cases happen. That will be what is cleaning up the entry. We could also just remember what we implemented the last time, but let's see. So chat end and chat end here, yeah, it is responsible for cleaning this up. So we will just this or that. The nice thing here is that if this condition is true, the second one will not be even tried. But in this case we don't want it to be tried, so this will be larger 0. So if we find something in the file sessions, we don't remove anything from the chat sessions, we just emit chat ended event for this session, and that's it. If this returns null, so we have not found the entry to be a file session, then we try removing it from the chat session, and if the second succeeded, then only we will trigger our chat ended signal. At this point we probably should rename chat ended to session closed or something like that. Since or we could have two signals, one for chats and one for file transfers, which probably would be the most elegant solution. So let's go with that after quickly testing that now it works as expected. Yep, as you see, both entries have been successfully removed. So now we will quickly search for chat ended and then create a second signal, transfer ended, and then we will of course have here a new connection to a new signal. So we also need a on transfer ended, obviously, and then we need to split the functionality. Right, so on chat ended only needs to do this, and on transfer ended only needs to do that. And the last thing to do, of course, is to emit the right event at the right point. So here, if the first one is the case, oops, then emit transfer ended. Else we check if we can remove something from the chats, and then emit chat ended. Why is this complaining? Do we have a typo? Oh, because we are missing a closing brackets. Now that should compile. Okay. So one thing, of course, is what we can test is whether chat edit works properly, and that it does. Now we'll retest our send file, hopefully for the last time. We already spent some time on trying to get it to work. Interesting. We broke something, or it's random. Let's try sending another file. Maybe I selected the same file name twice and that's why it failed. So we definitely need to add some failure, some error correction. or rather error handling, because this is not great when we get an error. So let's try to add some error handling to our mechanism. So we have our chat session. The error will be on the read side, so ready read here. File is already open, so we need to find the place where we open it. File data, write open, write only, and if this fails, so if opening file for writing fails, then we will send back some sort of error message. And we also should, in case it was successful, send again back a command instruction that tells the other side that it can start sending data currently. The way it is done is that it just sends file data and then just starts sending the file content. So we'll break this up into two individual discrete steps. So of course, if error, then we have some error. Else we prepare everything for receiving. Right, so we have here our control. So we will not send any argument. We'll just say right, and we called that file data. So we should probably name this also to file. There are a few things which we should improve. So first of all, we should collect all the different available command words somewhere. So probably here at the top. Oops. Will be a good place for that. We can split the view, and also we should stop it so that we have more screen real estate. And then we'll be collecting them. So hash define msg, then some name, and then define. It will now complain that the names are repetitive, but this is to be expected. Name. Then we have pod. It is generally good practice to store all the possible constant values that one has somehow as defines or as enums if they are numerical, because this helps you avoid issues where you would, for example, mistype something and then it would cause you problems, because you would not have, you might haven't noticed that you have mistyped something and then something is not working for a not obvious reason. If you use a define, then mistyping the define's well, name text will cause an error during compile time. So it will be very easy to spot. So file, then we have accept. Also, it is quite useful to avoid issues where you would, for example, use the same variable or the same value rather for something, for whatever, because if you do, then again you would cause a an error during compile time. So the system would notice that the name of the that the name of the define or of the enum has already been used, and then the compiler would complain. So, and last but not least, of course, it helps you to find a consistent naming scheme. So for example, we start with file offer, then we send an accept, or we close connection on decline. We could actually have a explicit decline message, but we don't need it, I think. And then we would actually want to start sending data, and this sends us this file data element, this file data tag. I'm thinking we could, in principle, when we accept, then open the file. So we could kind of automatically just decline if we fail to open the file, and we already have a file size, if I recall correctly, right? Because when we send this accept file, the file name is a new file name, but the file size we should have from the earlier request. So in principle we could move this functionality here to our accept, so we will not care for the arguments. We just here have the check that if it wasn't accepted, then we hard close the connection. And then here when we have our accept file, we already have the file name, so we can now start the progress timer, create the file, file data pending, file accept pending. I think that had a reason why we did it this way, right? Because we want to switch it later. So okay, so let's do it this way. We'll keep some of the functionality here, but the other portion of the functionality we will move already to the other function. So we keep file data pending true here, because this switches the connection into receiving mode. So at this point, when we would have changed this, we could no longer receive any commands earlier. And we will update file size again just in case. But here, when we say accept, we will already want to open the file at the designated file name. So if it's successful, we say accept, and in the else case, we will send a decline. Did we actually implement a decline function? Let's see. So right, so here if at any point we say no, we just close the connection. So since this kind of is our default approach, then here we will also say that if it failed, then we just close the connection, and that's it. The advantage of a decline would be, of course, that we could somehow display an error that something didn't work. Also, what we can do is the accept function itself can have a return value, so that we could display an error to the user that something failed. So let's quickly change the order of operations here. Return false on open failed, else we return true. So now of course we would want here so if this is false, then q message box, what was it, critical, this comma, what did we use as a name for our tool, okay. C file comma transfer botted, right. So if it fails, we'll show an error message. The other side will not get an error message, but we probably would want to. So we should add here a flag which will tell whether it was the sending or the receiving end of the connection. Right, so we are here on file send, and we start with the chat manager send file, which then starts with start, and here it sets a file name. So here we can set a flag that will indicate sending a file. Let's call it file offer. By default, this will of course also be false. here it will be set to true, and then we will add here a small helper function to tell us whether this was an offer or not. Or is the offer const what did we call that? MP, I think. MP. Okay, I don't remember. Without P. And file offer. Semicolon. Zack. Okay. So now here on the messenger, on transfer progress. It should be on transfer ended. There it is. Here we can check if this was a if file offered. So if it was an offer, then we need to check whether it was successful. So if offered, and so we'll add another flag here. File offered, file accepted, that will be the last one. File data, file completed. File. We probably should call it transfer completed, but well, the naming is very much up to one's personal taste. So if it was an offer and it was not successful, then we will show an error message. Since we are lazy, we can just copy the error message we have crafted earlier and just slightly adapt the text. So file sent, the title failed to send file. Right, so this way we can notify the user that something went wrong. And we of course need to save the data that the file was completed, the information the file transfer was completed somewhere. So we go back to our session, and where are we sending? On control message, continue send, start send file right here. So continue send file. We try read 0. Bytes written. Let's see where we close the connection. It's close on the other end. Yeah, it is close on the other end. So the receiving side is usually closing it. So let's see on ready read write. It makes here close. So one thing we can of course say, we can also here say file completed. But we should somehow say this on the other side as well, set this on the other side as well, because on the receiver side we actually don't care for the flag currently. So let's think how we do it best. So send file. We could do it simply by sitting in the close in this event here, and if file accept file offer. If this is file offer, and then we'll check if the file file right don't do this, we only do it there, right? So we also want to delete this and set it to null. But we need to check this. So file size is of course the wrong thing to test. What we want to see is if the file is size is position. If the position is at the file end. So this kind of assumes that we have read the file until the very end. Although we could probably always get rid of the file, so let's make like this. So if we of course need the file to be open, so if the file is open, then we close the file, but before we close it we check whether it was completed. Okay, so let's try it out. We will try to intentionally now cause an error by saving the file under the same file name. A file open for reading cannot be open for writing unless this is especially specified in the when opening the file. So this is an easy trick to generate an error usually, since we are not setting that flag. Okay, so file failed send file, and the other one did not complain. Why did the other one not complain? We wanted both to complain, so let's see. Right, that's on the no, the accept end. It should actually cause an error. Let's see. We reset the breakpoint and just try it out again. Oh, because the file has a size of 0. Then let's take one which is not 0, like the other one here. Right, so we have here our accept file. You know what? It will. So we will successfully open it because it opens for. No, it will not. Was it open? No. Yeah, we open it successfully for writing before we open it for reading, because we only open it for reading once we get the file accepted. So we need another way to generate an error that would actually fail on both sides. We can simply select the file we know is open, like the original here PDB, which will be opened by our debugger, so it will not be writable. And now we should get the error we want. Yep. So now we get the first error and the second error. Failed to save data transfer aborted and failed to send file. We could add the text that the transfer was aborted to both, perhaps. Oops. Transfer aborted. Okay. And another thing which we could improve here is that instead of just closing the connection, we would set some error message. So we would say, for example, error opening file or user declined, so that we know whether we should try to send the file again or whether the user did not want to accept the file. This will complicate our program logic a little bit, because we will need to kind of send a replay to the other side, and then we either just let then the sender close the connection, or we make it such that we automatically close the connection on a timer after we have declined. Both options are fair. I don't think there is a particular preference. If one would want to be more safety minded, then I guess it's a better approach to close the connection from our end on a timer. But since we are making here a more of a collaborative tool, not something that would be initially intended to work in a very hostile environment, we'll just for now let the other end close the connection gracefully. So we will need to change it, so we go to our chat session. Right, and if we try to accept file and this fails, then instead of closing we'll be sending a control message with an error. So we don't say accept, but we say decline. And then either we specify a reason, or we specify no reason, which means that the user declines. So open failed, and this of course means we need to add a function decline file, which will then send a decline without a comment. Decline file. File name is not needed in this case. We could kind of be very unprofessional and just say that accepting a file with an empty file name means declining a file, but this is really bad practice, as it well, it works. It makes the code really hard to read, and you should always try to make your code as readable as possible, not just for the sake of others, but also for your own sake, if you at some point will have to remember what you have programmed a few weeks or months ago. So it's not that usually you think that you remember everything, but you won't. What was a decline? That's something I know from experience. Give enough time pass and you forgot whatever you did. So try to make your code readable for someone who is not familiar with it. Right. So we have here our decline, and then we will also need another message for notifying that it was completed. So not just accept, but file. Either call it success and then just send the transfer was successful. We could have a error message which would specify that something didn't work. Let's for now go with success. That's we can change it later if we want to complicate things. Right, so we see here we have our send message, and now in the part which is receiving the data on ready read, here we set file transfer completed, and then we'll send the success flag, and the success flag now will need to be processed by the where did we put that? By our onControl message function. So on success, and what do we need? What does this function need to be set to have a meaning? It needs to have a file offered, must be, yeah. So if file was offered, if it wasn't, then it just then you can just return. We don't really need a success message. We'll just close the socket from the sending side if everything worked out as expected. Right. So let's try this again. We did not do one thing. We are not handling the discard message, so we should handle this as well. Message decline. We will handle it the same way, but we should store the parameter somewhere. So we could add here a new variable, string last arrow. We'll have a variable called last arrow, which will contain the last arrow string we want to communicate to the user, and this is actually not that bad of a strategy. Why is this complaining? Is this type string? It should actually be yes, because it's a list. We need to take the first element of that. So we could have like arrow string, vertical bar, and then some other data, but for now we just only take the first one. And then we of course need a function to retrieve our arrow string. So string get arrow string. string. So in our thing here, is offer, then is file offer. Is file offer, right? So here send failed, comma reason double point %1 point arg. Now we get the last. It could also be that we get like an empty reason. We should handle this. Okay, so if get error string punct is empty string. Let's do it like this. So we set temporary variable to the value, check if the value is empty, and if it is empty then we say user declined, and else we will take the value that we have received. Also note that the value received is not in this tr brackets, so it's not localized, which is obviously reasonable if you are sending something over the network. So ideally here we would then check if error is any of the known error values and then localize it on the sender's end. And of course if it's an unknown error code, then we would probably say like unknown error string and then have the string as is. Right, let's see if right, so we start the chat, we send the file. We should add a send file button, that would make testing more convenient, I think. Right, and we will just decline. So we select the file, we say no, and then we get a nice error and no subsequent error. Now we try the same thing, but this time we will try to generate an error. So we'll try, for example, to send a file which cannot be overwritten, and then we get failed to send, open failed, and here we have failed to failed to open file to save data transfer aborted. So now the other end would know, oh, something failed, so I can try again. What we also could try is like create a loop. So if the open failed, because we know that this is like an unexpected error, so if this happens, then we then just go back to here, and the user has another option to try again. So go to retry, failed, so failed to open file to save, and not transfer aborted, but failed to open file to save data, comma, select another file. So we get an error and then we go to retry. I'm not sure that it will compile. It probably will not, because we have here a variable defined within the goto, although it sometimes depends on preset. Oh, it compiled. It depends on the compiler preset, because theoretically for this one it might complain and want us to put the just definition before the goto, so that all the that basically it doesn't need to unwind anything, that all the variables live before. But since it was fine this way, then we just leave it as is, and we will try the error. Yeah, and we will wait. Did it? Now it says it is not. Right. So we have our file saved properly. So in case we want to set a breakpoint somewhere, it will not complain that the file has changed. Now we will repeat our intentional mistake from before, and try to overwrite something that we should not be allowed to overwrite. Now we get failed send file reason. Oh, haha. We have sent the message. So now what we would need to change the way our accept file work to just return the failure, but not tell the other end that it failed. So this way the other end will not abort it, they will still wait for the accept, and we have the opportunity to try again. So yeah, so that's that. Any questions about our chat messaging app? Any suggestions which next features to implement? So if you don't have any suggestions, I would just go as the next thing with adding some hashing to validate that the file was correctly received on the other end. But if you have an idea for a feature that you would want me to see me to add, something that is not too complicated, so no sound or video, but some simpler things, then you can suggest it at any time. Okay, no one is saying anything, so I guess error correction it is. So when we are starting the transfer, somewhere files, where was it? Connect, socket ready, right here, this one, file data. When we are sending file data, what we are here doing is we are sending the file size as well, but at this point we could first read the file and compute a hash value. This would require us to read the file twice. So for small files it is fine, but for big files we might not want to have to reread the whole file. So if we want to be super efficient with our protocol, then actually we should send the file hash after we have sent the file data, because this will allow us to compute a hash in real time. And there is a nice function for that, Q cryptographic hash, which can compute, as you see here, quite a few different hashes. And the way it works is we need a variable of this type, and then you can you initialize it with the algorithm you want to use, and then you just call add data as many times as you want in an arbitrary increment. So there is, so whether you break your data up into 10 chunks, 100 chunks, or just give it in one piece, will have no effect on the result of the function. And once you are done, you can retrieve the result with result. And then of course, if you would want to create a new hash for some new data input, you can reset the state at any point in time, or you could, I guess, continue adding data and then get another result for a bigger data set. Normal hash functions usually work like this, that you have like some initialization, and you have add data, then you have finish, and then you can retrieve the value. And of course you cannot make add data after finish, but seeing the functions available here, I guess that when you call result, it will do like a finish operation on a copy of the current state and just give you the value, giving you the opportunity to add more data. We could try whether this works or not, but it might also be, yeah, I think without reading the documentation, that's the most likely implementation they have chosen, since Qt usually is not in the business of throwing exceptions. They only use return values, and returning an empty result after you have added data again probably would not be great, although we could also see here, but I think that for the return true if record was successful reading. Yeah, so here we get a return value, but it only refers whether the read operation worked or not. So there is no means for the class to communicate if adding data after retrieving the result that this would be an error. So it would stand to argue that they implemented it such that it will tolerate such behavior. So let's include our hash function somewhere here. And we should also implement it as a pointer like we did with the file, so that we can hash is equals null, so that we can create it when we need it and then dispose it once we no longer need it. We can also use it on the receiving end and hash the data as they come in. So this way we also avoid rereading the file from disk. At this point we assume that there might be an error on while the data are communicated over the network, but we assume that there will not be no errors on the local system, so that we kind of saved something to disk, and then when we try reading it we'll get a different result. This is a scenario which with very old computers like DOS ages was something that people might have to worry about, but nowadays such things, if they happen, then they're indicative of a major hardware failure, and you should replace your hard disk as soon as possible. And also, they don't happen often, and if they happen, then the operating system will notice this and notify you, or it will just crash outright, depending on where the error occurs. So it's not likely that you would have like received the file and thinks everything is fine, and then when you read it a week later from disk, then it would not work. So this usually doesn't happen, so you don't need to care for this case. So per file equals new. So we will at these both places also create a new hash, new cryptographic hash, and let's go with SHA-256. This is a good hash function. It is safe enough. Okay, and now whenever we read something from the file, here we will add whatever we have read to our hash at data. Use the same buffer variable, but we specify the read, and of course we should move this a line further down, that we only do it on success. So if we read something, really read something, we add the data, otherwise we don't. And then of course we want to do the opposite. So do we have file write socket, file write here. Whenever we write some data to the file, we want to put it here, and let's see, we have a byte array view that should work. So here it just accepts the byte array and writes it to the hash. So once we are done here, we will get the result byte array hash is equals hash, and after this we'll also delete it and dispose of it, since we won't need it anymore. File completed. We should keep this. We will change the behavior slightly later, maybe, because the way it works now, we assume the file is completed when we are done writing it, but we don't know whether it is intact. So if we send the hash back to the other end to validate it, then the other end should tell us yes, the file is fine, and then only we will set a file completed. But for now we'll leave it where it is, and we will just send the hash and the vertical bar back to the other end. So there we will add some handling for the unsuccess message, and we should probably change it from success to something else, like completed, because we don't know yet whether it was successful or not. So here we split our parameters, and now we will check whether the hash is fine. So we also need to get the and finish the hash, so do like this. Right, so we have on success, right, and we have not closed the file, so we can, because here we automatically close the file if we have not read anything else. So what we would want to do is we would want to move this to the unsuccess to be later the incomplete thing. Right. So our incomplete function will close the file here for our sending side. And then we have here the hash. Now we compare if params 0 equals hash, then really it's success. So we want to first rename this to how do we call it? Because we want to indicate that we have all data. Let's say file end. File end. So instead of success, we just replace this with file end. Right. With our file end here, if it is successful, file completed. On disconnect, we will remove this as well somewhere else. Right, file, and we should also dispose of the hash in case if enter hash, enter hash. Right, then we go back. Right, we have a file complete here, which we don't want to be here for now because we are waiting for the other side to replay. And on this end, now if this hash is true, then we can set that it is completed, and then we will send the successful message. Without any arguments. Oops. Right, so we then send success, and then success will here be processed. Now we change its meaning, so we need to again check whether the file was whether a file was accepted. And if a file was accepted, then here we set success on true. Right, but then we will need to close the connection, because if we kind of send and then close, then there is a chance that the data will not really be sent, although on a TCP connection usually it should be able to handle this correctly, but just to avoid issues with our own mechanisms, let's just move the close to here. Right, and then we know that everything worked if the hash that came back is the same. So we'll put a breakpoint here and now run our function again. And then we'll need to think if we just want to notify that there is an error on an error, or if we want to automatically retry the file transfer. I think, well, some intelligent error correction would be nice. That is probably too complicated. We will here just show an error if something happens, and that's it. So we have a hash value. Oh, right, that that there is a small error. The hash is basically a binary. What we wanted, we should have first converted it into some nice representation. So, for example, to hex. And here we'll compare it with the hex value. Right, so let's try again. And we kind of don't see the content of the first one, but we can see here that we get a nice hexadecimal value, and we can see whether they were the same, and they were. So this should work fine, and it did. Now the question is, how do we handle the case if it's not the same? So there we will need to return some error message. Failed. Hash mismatch. And of course we need to handle the other the failure message. Again we will close, but we will set last error to be the parameter which we have got. M last error is equals params 0. Okay. Good. So we want to kind of cause the error on, well, intentionally. So we will just comment out the whole if, and then we will always say that there has been a hash mismatch. One thing that of course could also be done is now to add an option that it will automatically delete the file it created, knowing that it is not correct. But I think that's too much of a small optimization. Let's pick a smaller file this time. It says user declined. That is not expected. Why didn't we get an error? Let's put a breakpoint here and see why last error was not set to the right value. Where we are getting the error. The first one is hash mismatch. We should be on the receiving end. We can quickly check it by inspecting the object. So we should have yep, file accepted true, so we are on the receiving end. So let's see what went wrong here. We get an error, but that one is empty. File is offered. File is offered. We didn't actually, should have two errors. One here, obviously, because we are on the sending end, but and we should of course set the same error on our sending end. I forgot about that. But it still means that we have another issue, that because we are not showing this error on the receiving end, right? Because we are not this is obvious, because we are not here we have this what was it, file offered. We'll check that. So always when we close a transfer and file is not complete, then we will display the error message, whether we were the offering a party or the receiving party. But then we of course should not call it file send, but file transfer. Transfer. Right. So file transfer. File transfer failed. Reason %1 transfer aborted. You kind of don't need to tell this again. So let's just run it as is. So we create a connection, we send the file. We select a smaller file again. And file transfer, reason hash mismatch, 1 error. Well, we get the same error twice now, but that is what was expected. So this is working. And the next thing we could think about is whether we want to try to add some error correction. So before we do that, we should definitely write down some protocol specification, because as you see, we already have here quite a few different command control codes, and they are doing different things, and they only are valid in different scenarios. So for example, file data is only accepted if the file was accepted, so we already have a check for that, so that someone doesn't try to bypass this. But ideally we would want to kind of formalize our protocol, and what also would be good is to add some more reliable state checking mechanism, so that we don't need to check all the variables each time, but something that would for example offer us just a few functions which will just return true or false, and would be used to validate whether the connection is currently in a specific state. But before we start that, are there any questions? Okay, no questions. Good. So then let's start. We will have I'm thinking how to best write it down, because we have kind of a bit complex protocol, but for simplicity and in order not to introduce any additional tools, it would be best if we would just write the protocol as a comment. So let's just create some larger comment text block. Also, let's move this to the main window here so that we have more room. Zack, and then we have, of course, let's send and receiver. It's also nice to probably have a another matter. Okay, so we will want to specify a few different things. So just a text chat, text chat, and we will want to have another file transfer to. Okay, so how did that work? We have right, send and receiver should always be at the top, and maybe we move this a bit further in and make this a bit longer. Right, so in case of a text communication, the sender I guess the sender does something. Let's see. On connect, send control, send the text, we start the session, start. Right, so we make a connection, and then on connect we send name and port, and the other end does the same. So send in a text connection when the connection is, so basically the first step will be connect, receiver will be accept, well, it must, and then both ends will send from the on connect. Since the on connect will be triggered for both, they both will send the name and port command code, control code. And the way this effectively will kind of happen, we should actually move this like into different lines, is that the accepting side will kind of send their request first. So MSQ. I'm thinking how to of a good notation. So let's just go with this. We just send name we'll be using just the strings after control message to denote what's happening, and in square brackets we'll denote maybe not capitalized the operations of what is happening network wise. So it sends name and it sends port. The other end does the same. Okay. Right. And if this is not a file transfer, both is this so on connect? Start session, we trigger on connect, and the other connect ready. Now that should work as expected. So we will then send an empty list each time. Why do we want to send empty list? Because both sides want to know what the other side, what data the other side has, on what, maybe not data, but what context the other side has. So we have here our list, and we also send text to notify that this is a text communication. And I already see here one error. The other side is kind of sending this text field, but the other side doesn't know what we really want to do. So there's actually a logical bug already. This request should only be sent by the connecting party. List and text, and then the other party should reply with a list on its own, kind of as an answer on the text request, and from there on we will then just have message text and so on. So now they can communicate as long as they want, until the socket gets closed from one of the ends. And those I will put in the same line, because it's kind of not specified which end will close the connection. Either one can close it, and then it just closes. Nothing that happens after it. We could in principle have here a small specification that the communication is going zack. Here we just add and here we make either way. Right, so on connect is a slot which is either triggered really from here, or it's triggered from the like artificially from here when we get the incoming connection. So let's just make a new function which we will use instead of the slot. Void send handshake all just this one, nothing else. This will be a short function. Oh wait, I think I went into the wrong header. Yes, I did something for here. Yeah. Okay, send handshake here. Where were we? Right. So on connect. So on connect is triggered when we have a connection established, and it is triggered only on the sender side. So here now enter our send handshake call, and then where we have been artificially calling on connect on the already accepted connection here, instead we just call send handshake. So now we ensure that I'm missing a semicolon here, that our protocol will be kept. So the connection is well established. We accept it on our end. We already sent our handshake. The other end sends their handshake, and then in addition to their handshake, they will send us either the file or the list and message. And the next thing we would want to is, if we receive the text event, then we would want to kind of send list to the other side. Oh, and I see another problem. We are not sending now the text anymore, so we are missing we will be missing one. We will be one event short. So if we try to run this now, it's likely that we will not get one of the two tabs open. Let's try it out. I mean, we might have used an auxiliary method of... Actually, it worked. It worked even though we only created on session once. So it just means that we already have created the chat session before. Now, if we put a breakpoint here, we should see that this only should be triggered once. Right, it is only triggered once, and as said, this will be triggered on the other end. So we will just add here a list command. Because the other list was already sent. So this way we will ensure that we start the text session and that both ends will receive their list of contacts. So yep, we could of course change kind of the order here, first send text, then send list, but it doesn't matter. It is fine the way it is. We could add a comment here. This is sent only by the connecting client. This can be sent by either client as well as the other headers. So this is already our protocol specification for our chat connection. And now we take a look how our file transfer looks, which will be a bit more complicated. So here we connect. We send again name and port, that we always do, simply so that the other end knows with whom they are interacting. It might be an improvement if we would combine those data into like one larger data block, like name, port, and maybe something else, and then just call it hello instead of name and port. That is an improvement which we may add later. But for now, the idea would be that we now send file. Where do we send file? What was the name? Yes, file offer. And the other end can either accept or decline. So they can accept. Transfer. There will be different use cases. So let's do it like this. We send a file, and now we make like 1A. Decline file 1A punct decline file. So now from the other end we are not accepting but declining, and then what happens then? Then we should close the connection on our side. Success file and file decline. Yeah. So we close on our end, and then the other end closes on their... Well, they don't close, it kind of gets closed. So we just say from our end we close. Now on sorry, and it's of course case 2 and not a 2b. Accept file, and special case transfer OK. So the other end replies with a accept this time. Right, so where we are here, we get the accept, then we do the start send file, so then we send file data. File data, and then after file data we will be sending a lot of file data. File data, a lot of file data. We could actually call it like file data 1, 2 until n, because there are many file data that can be transferred. And when we are done sending file data, what happens then? So this side doesn't do anything, right? The file data is accept file, where were we? Right here. Once we have received all the file data, then the receiving side kind of says file data end, and this kind of is necessary because we don't have a mechanism to switch out of the file data streaming mode. So we call here file end, and there is of course a error condition which we have not yet handled, is what would happen if we receive a file end before we are actually sent everything, because this would be something that could happen as an error condition and which we would want to somehow handle, but it's for later. So here we say file end. So file accept file data, file decline, file end, and now from this side we said it will be a successful transfer. Actually, I would rather say case B, file end, and then now the sending side. So this we will kind of make like 2b I and II, or b1 and b2. File accept. So in the successful case, we receive as the sender, we receive the hash of the file, and then we will answer with success, and then on success the other end will close the connection. Or if there was an error, we reply with an failed, and the same thing happens, the other end closes the connection. So what we would now of course want is to extend this with some error correction. So if we say right, so this is the sender, this is the receiver. If the sender says failed, then the receiver has the option, instead of closing the connection, short case, and in the long case, this will then A1B number 3. We fail, and then we reply something that we want to try to recover the data, so we would request a hash set, or we could request a hash tree. Yeah, let's be simple about it. So we'll just request a hash set. So echo hash echo h set. Just call it request hash set, and then alright, and we forgot to specify the connection what happens here? Oops. Request hash set either and can close, right? So we said that connect and accept. Here let's give them some errors. Right here we have accepted and close. So notify who closes the connection. Close. Right, decline close, close. Yeah. Okay, so we request the hash set and then we will get the hash set. And then once we got the hash set, we will need to check with our file and then request a block of the file to be resent to us. So let's say request block, request let's say request chunk. Then here on this end we will chunk data, and then we will send the chunk data. 1, 2 through n. 1, 2, or just 1 through n. Let's not waste space. Right. 1 through n, and then this side would then reply the same way. Chunk end. chunk data chunk end, and then we could in principle request the next chunk if we have seen that more than one chunks are broken. So our protocol was that we send file end, and then the other side says whether everything is fine. So we will, I guess, stick with that. Let's see what file end actually does. Well, it closes the file, which is not necessarily desirable, because if we close the file and dispose of the hash, we cannot recompute it. So right, we will be improving on this slightly in a minute, but the idea would be that we would here, probably after we have got all the chunks we want, just send another oops, we can request more chunks if we need, and then we send file end with the hash of the whole file again after we got all the chunks we thought were broken, and then the other side will repeat telling us whether the file is okay or not. So then we, after file end, we continue the same way. So let's just be optimistic and say that it is successful. Oops. But we could of course also have the bad case where it says failed, and in which case we would then, probably in this case we would then just give up, because we got the chunks. Well, we could got them broken again. Ideally we should kind of test whether the same chunks were broken which were broken the last time, or in which case we do a retransfer, or if now new chunks are marked as invalid. Plus we don't need to request the hash set anymore. Yeah, but let's continue with this protocol, or we could of course improve it. So it's kind of not super elegant if the receiving end tells us if everything is fine or not. That should be kind of something that we decide. So we could improve our protocol from the get-go, and add. So we have file transfer, we have here file end, and then here we would have we would request a file hash. Request file hash. We would get the file hash from the other end, and then we would then tell it whether it was success or error. Or whether we want to request something else. That would be more elegant. So let's start with this small rework. So first of all, success and failure we will maybe comment out for now. We'll just add a request file hash. Wait, we will first of all let's think about it. We need a message to close the connection from the receiver side. That we need, or at least to tell it that we are done with everything. I mean, we could just close the connection like we did before. So we kind of would need to tell the other end success and then close the connection. Let's try this. It sounds like the most reasonable. Although when we are closing the connection, we're only closing the socket, that should be fine. So let's say that if we get file end for now, we will just we send file end as the receiver, and after file end we could, if we want, just close the connection without doing anything further. Right, so we check this, and if we don't want to do, we send file end. We need to send file end actually, because in principle the other side should know that it is the file is at the end. Okay, so let's maybe add first a flag that will tell us data pending. What did we use data pending for? Data pending was used on the receiving side. And we should we could reuse this on the other end. No, we'll use another variable that will tell us that the other side is still sending. So let's say we will rename the variable first from data pending to in principle we don't need this information, we don't need this change. Let's just do it like this. We start, we have a oops. So we start with we have our file, we have our hash, then we are starting on the sending side. So nPerfever equals new. So we are here on the start send file. So we create the hash, we create the file, and then we will just want to save the hash result somewhere. Send file hash, right, so that we know what we have sent. Then we have here our continuous send file, then we had here our on bytes written, and here we will change this back to how it was before. Let's quickly check how it was before. We did a lot of changes. Right, that was nope. Yeah, that was our old code. Also, it's kind of apparent that it is good practice to first write down the protocol specification and then start the implementation. The way kind of we did it is a bit the wrong way around. Okay, so on disconnect and we clear anything anyways. Here we have our file pending. We are here on the receiver side, and here, right, this thing is go away for now. They go in here. Right, so file cleanup, we don't need this, we don't need either. When we want to save the hash and dispose of our hashing function, because we won't need it anymore. We know this. We only want to keep the value that we know what we have sent to the other end, so that if the other end requests the hash to validate whether it receives the data correctly, that then we can provide set data. Right, so here let's comment out a few things. Right, and now let's go to here we are done. Here we are done as well. We don't need to close the file explicitly. That will be done by the automatically by when we delete it. Right, and we have one edit here. Yeah, file size. So here, well, we received everything, so we can close the file. As mentioned, we don't necessarily need, because delete will do it for us. We set pending to false. We finish our hash. Well, we could maybe rename this just to file hash, because then we don't use the connections bidirectionally. So here we kind of set file hash to hash, and then we kind of could just close. So this is the simple case where we don't want any error correction. We quickly test this, and then we'll add the request for hash and other things that we might want. Also, I think we forgot to set success, because if we don't set success, then the other end will think that there is an error. So before we actually test this, let's do that. So we set file completed true, and we should send some result to the other end. So right, this will be one case. This is the other case. Control message file result. Okay, message file result. Right, so we need to update we will not use file end anymore. We will be only using file result, I guess. But only, well, not really. We do it either. We only do it when we don't request it. So for now, let's ignore that. We need to update our protocol specification soon, but first let's implement it until it works. So file file result. So we send file result, the other end then can handle our file result. File result, that means we must have offered a file, and now we have this one. So param if null, is equals okay, then we can set file completed to true, else we set m last error to whatever param 0 is. Alright, so now the transfer should work without an error, and then we will re-enable the new version of the protocol, so where we actually request the hash and then continue from there. So we start the chat, we start the file transfer, we should pick small files for speed. We want to save it somewhere here. Okay, something is not as expected. Probably the closed before the other end closed. That is something I expected might happen. Let's see if we can flash all the data that were on the connection, because as said, it is a stream of data, and the disconnect flag flag should be sent in the last package, so it should in principle, if it would be just plain TCP, probably receive everything, but of course there might be some asynchronicity and Qt's own handling may mess up the order of operations. I have not tried this out recently. No, it still fails. Okay, so we will I think just let the close be done by the requesting party. So after they received the result, they will close the connection. So now it should not express any errors. Zack, 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 zack. Right, so we get here our hopefully successful wasn't it successful? Oh, that was a bug on my side, so perhaps the other closing was okay anyways, but we'll leave the close to be on the requesting user side for now. Which approach is more elegant is again up to debate. That is reasonable to let the requester be the party to also terminate the connection. Yep. Right, we should maybe show a successful message or something, but well, so this worked. And now we will look for the other case where we just request the hash. So we make an if1. Later we will add here some sort of a variable that will be user configurable. So to do add setting/option, such that we can specify whether we want to verify the file integrity or if we don't care and just finish as soon as possible. So in this case, we send the hash request. Wait, right. So first of all, this is wrong anyways, because this was the old protocol. The new protocol needs the hash request. Hash request. No, let's call it request hash. Also, this file, maybe you should call it of a file. And the nice thing is that now an accept file, that now we can change this here, and it will apply to well, it will apply to wherever, since we are referring to this names and not the strings themselves. Right, so we have file request hash, hash file hash. We could also call it a hash response. Maybe that's nicer. Hash response. But then we'll also kind of call this hash request. And let's maybe keep this short to not waste too much overhead. So we have our request, we have our response. Now we will send the hash request without any arguments. Oops, zack. Now we need to handle it. Right, we will handle it further downstream. Oops. And this will just return us a hash response. So in principle, if we are the sending party and we receive a file end, file end we don't longer use, so we receive a file res, then we could kind of still request the receiver to give us their hash and validate on our end still whether it was successful or not, even if the other end did not set that flag. So this makes our mechanism quite flexible. Because the hash thing just replies with file hash, and then the other end. For now we will only implement the send case again. So we get the response. If we get the response, then we must have requested it, and we must have requested it means we must have accepted it. So if we have not accepted it, then we just don't do anything. But if we have accepted it, now we'll test if file hash is equals one quick check. Right. I will save it as hex in the variable. This wastes memory, but it makes for a much more readable implementation. Right, and here we of course need to get the param 0. So file hash must be equals param 0. So if it is, then we are happy, and then we send then we set success. Right, one more thing. No, that's fine. Okay, so then we set success and reply with OK. But if they are not, then we will want to somehow handle this error. So as we said, then we will send a hash set request. And this means we should implement some hash set calculation. So we need a function for this. Let's create a request and response. Let's call it h set reco and res. I think the names here are slightly different. Okay, so I think before we proceed with this, we should first fix here our protocol. So we have our decline option, and we have our file data. And if we are done, we request the file hash, we get the file hash, and then successful case. Then we reply with this things change. So this goes away. Here we have close, and this file, and this is then just hash req hash response, and here file res, right, we close, and here file response, we just sent back successful, and we are done. And in the error case, well, in the short case, well, let's say there's no error link, that can be okay or failure, right, which also means we need an option to, no, if we don't request even the hash, no error handling, yes, to be, and in this case we will always request the hash. Okay, so we need to change a few things. So here, right, but we had hash request. So okay, so this is not no error handling. That's the success case server. That's the hash error. So now we will send, right, so we get the hash set, then we send a request hash set, h set request, we call that, h set cool, we get the hash set h set response, then oops, then we check what's wrong, and then we request chunks until we are done, like chunk end, and then basically at some point we are just satisfied, and then say file success or file error, but we just say something. We could in principle here then retest against the hash we got, which we'll need to do anyways, and we'll just request chunks. So for the protocol description this should be already enough, right? So we have our hash set request. And now one issue we have not thought about is the hash set calculation would require the whole file to be read again, which in case of a very large file would take a lot of time, which we might don't want. So ideally we should calculate the hash set while we are already hashing the file as such. So for that we should replace the qcryptographic hash function with a own class which will implement all the functionality needed for hash sets and error recovery. And then we will be calculating the hash sets like in real time. I think this is an approach which will be most well, will offer the best performance, let's say it like this, because then we will never need to reread the file, and if we choose a reasonable ratio of hashing for our hash set, then we will not have much excess operations. So if we, for example, say that we always break the file up in 100 chunks, then we will just have 100 additional hash operations, which is negligible. And as mentioned during the last lecture, the other option would be to have a fixed chunk size, so that we say that a chunk is always let's say 10 megabytes large. What we also can do, of course, is we could go with a hybrid approach. So we say that we break the file up in either 100 chunks or 10 megabyte large chunks, whichever gives us more chunks. Because if we would have a very large file, then we would of course not want the chunks to be hundreds or even gigabytes in size, hundreds of megabytes or even gigabytes in size, because then of course retransferring a single chunk would take a lot of time. On the other hand, of course, if we would have too many chunks, then at some point the hash set itself would be very large. So we could even have an approach like we always have at least 100 chunks. Then we scale allow the chunk count to become more if each chunk would be more than 10 megabyte, but then again we apply a cap that if we only want to generate 1,000 chunks. So if we would have a file which is 1 terabyte in size, then we would say, okay, then one chunk will be a gigabyte more or less, and then we just have 1,000 chunks. Or we could maybe say we limit it to 10,000 chunks. Then we would limit them to 10 megabyte large chunks. So there are ways how this can be quite intelligently mitigated. As I mentioned, I think the last time as well, there would be also the option to make multiple levels of this hashing. So implement a sort of hash tree. This would allow us to pinpoint corruption in with a quite high resolution, and only transfer very little hash information forth and back. So that would be something we could think about as well. But since I don't think we can implement either of those solutions in the remaining 20 minutes, and I don't want to start something and then leave it open for the next few weeks without finishing it. So I would say the proper hash set implementation and error correction we will simply implement during the next lecture. And for now here we will just see if the hash is wrong, then we will just return has mismatch as an error code, and that's it. Just hash error or bad hash. Yeah, that's short enough, because hash error could kind of say also mean that like an error while computing the hash, but bad hash really means that it doesn't match. Okay, so this much to our QMessage application for now. Right, and since given that I didn't make a break again, as I usually don't do, we only have 6 more minutes left. I think this is a good moment to finish the lecture for the year, since the next lecture will be, as I think I already mentioned, the beginning at the 11th January, probably. Where's the January in my calendar? Yes, 11th. So there you have like 3 weeks, I think, for doing other things. Of course, I would recommend you to use the time to already start with your final project, since if you start with it and finish it, then you won't need to have it compete with other exams and stuff like that at the end of the semester. So my recommendation is to just get it done as quickly as possible. Right, and if there are no other questions, then we will finish at this point. Have a nice holidays and a nice weekend and so on. Bye bye.